So at the bottom of page 4, we're going to talk about a very famous postulate in geometry called segment addition postulate. And I went ahead and wrote postulates versus theorems at the top, so for us to redefine this based off of the video that we saw before. Go ahead and take a minute and write down what you think postulate means and theorem means, and then hit pause on your video. So hopefully you recorded something to the effect of that a postulate is a statement that is accepted to be true without proof, and theorems are statements or conjectures proven to be true. And I'll add an S right there. So what I'll do is I'll take this statement that I had previously filled out and then move it to the top of the page that we have so that you have it there to record. And we're going to start with what segment addition postulate means. So if we have segment AC, and again, the actual notation for it is AC with the bar on top of it, that's segment AC, as opposed to line AC. So segment AC, again, remember you cut off the infinite parts of it and you have a segment. If B is between A and C, then what you can conclude in this postulate is that AB, which I'll color code here, the length of AB. So when we refer to length of a segment, we don't need to write the bar on top of it. So when I write AC without the bar of it on top of it, it's the length of segment AC, as opposed to referring to the actual segments. So the length of AB plus the length of BC, so plus BC, is equal to the length of the entire segment AC. And so you might hear me say a piece plus a piece equals a whole. So a piece of the segment plus a piece of another segment added together is the whole segment. Okay, so the converse of that is also true, and we'll talk about what the difference is between an initial statement and its converse. But if you'll bear with me, let's see if you can figure out what a converse is. So if I rewrite that, and I'm not going to color code for this statement, but if AB plus BC equals AC, then our conclusion this time would be B is between A and C. So we can see that the hypothesis and conclusion are flipped in this statement. So both are true in this case. So an example of this would give you actual measurements for the length and then ask you to figure out either the missing piece or the missing length of the whole entire segment. So in example 1, RS is equal to TU. So again, if we're referring to the length of a segment, we're going to use the equality symbol, the equal symbol. And here, to denote that on my figure, I highly encourage that you guys are marking off your figures. There's a mistake on the picture. A is supposed to actually be U. So let's go ahead and change that. RS is equal to TU. So I have those little tick marks there to show on my figure that I know that those two things are equal. The length of ST is equal to 9. The entire length of RU is equal to 33. They want us to find the length of RS and then the length of SU. So first things first, we're going to find what the difference is between 33 and 9, and we get 24. So we're going to do 33 minus 9, get 24, and if RS and TU are equivalent to each other, then we can divide that in half and conclude that RS is equal to 12. Go ahead and hit pause and then see if you guys can figure out what the length of SU is. So hopefully you guys did ST plus TU must be equal to SU. That's using segment addition postulate. So if I substitute things in, 9 plus 12 equals 21. For example 2, you're given no picture. So in this one, we're given that Y is between X and Z. So let's draw a segment. Y is between X and Z. Find the distance between X and Z if the distance between X and Y is 12 and the distance between Y and Z is 25. So on our problem, we're asked to find XZ. So we can see that xz is the sum of xy plus yz, and that would give us the entire length of xz.